All right, we'll just get started in a few more seconds. Let's wait for some more people to join. Just a couple more seconds. All right, perfect. Let's get started now. So hello, everyone. Good morning, good afternoon. I'm Kundan Vyas. I'm a part of the product team here at StreamNative. I also focus on the partnership strategy, and I'm super excited to have a special guest today, Sarvar. Sarvar, do you want to introduce yourself?
Hi everyone, really glad to be here. So my name is Sarwar. I work as a field CTO here at Timeplus. We're a stream processing, streaming database company. Thanks for having me here.
Absolutely. We're absolutely excited. So let's get started. So we have an interesting agenda today between Sarwar and myself. We'll cover a few topics. We'll talk a little bit about the use cases for stream processing, the importance of having a simplified infrastructure for processing your data. And then Sarwar is going to cover a bunch of things, all the way from a quick introduction to Timeplus, and talk a little bit about the challenges in the world of streaming analytics, and then cover some of the architectural patterns. We also have a demo today. Let's get started. But I think before we get into the core content, I just want to, for the benefit of folks who don't know much about StreamNative, let me set some context. So StreamNative is a company which is created by the founders of Apache Pulsar. And back in 2012, this technology was created at Yahoo with both messaging and streaming technology. It was open sourced to Apache Software Foundation in 2016, and very quickly it became a top-level project in 2018. This company was formed in 2019 to offer managed services for Apache Pulsar. And it was a great period for both the community as Apache Pulsar and StreamNative to grow at that time. And then we also launched at the time, support for different types of protocols within Apache Pulsar. So again, thanks to all the committers of Apache Pulsar to contribute to this growth, right? And in 2024, early 2024, we expanded our support for the protocols and added support for Kafka. So we launched Kafka on StreamNative. This is Kafka compatibility using the Kafka protocol. So now essentially any customer who wants to evaluate our platform for Kafka, they can do that as well. So the one key takeaway from this slide is that StreamNative is both Apache Pulsar and a Kafka company. So you should look forward to more of our updates on both sides of these technologies. So quick introduction to the StreamNative platform. Right at the core is basically the support for Apache Pulsar and Kafka. And then basically we have a lot of different types of connectors which allow you to bring data and move data in and out of StreamNative Cloud. These connectors are built using Pulsar IO framework, which is for the connector framework based on Pulsar, and Kafka Connect based connectors as well. So we recently added support for Kafka Connect, which now opens up basically access to a whole range of community connectors and connectors from our partners, and making it easier for our customers to kind of quickly, build their pipelines. There's also support for different types of SDKs if you want to write custom producers and consumers to move data in and out of StreamNative Cloud. There is support for varieties of language runtimes from Java and PHP and Node and other things, right? This is, again, we have SDKs for both Pulsar and Kafka. On the Lakehouse storage side, I think, we have a support which is, we recently enhanced and launched and enhanced support for essentially offloading your data to low-cost storage services like S3 and Google Cloud and Azure in open formats like Delta Lake and Iceberg. And this is something which we are continuously enhancing and keeping up with the way industry is moving in the support of these formats. So customers can use an out-of-box capability within StreamNative Cloud today to offload the data to a low-cost storage service in an open format of their choice, right? So this is an exciting new capability, and that you should stay tuned to kind of watch more updates in this area. And then we support a lot of different types of processing engines and the querying engines. Essentially, we have support for Flink. We have our own managed Flink service within StreamNative Cloud. And then we have support for Apache Spark and other types of processing engines through connectors for Pulsar. And of course, we integrate with Timeplus. That's what we're here to talk about today. Right? We have a lightweight stream processing capability within StreamNative Cloud. It's called Pulsar Functions. It lets you deploy your basically stream processing applications in a language of your choice. We support 5 different language runtimes right now, and you can deploy these applications in StreamNative Cloud. And as your data comes into StreamNative Cloud into your topic, like these functions get automatically invoked to process your data and then put it in a different topic and push it out, right? So it's really a very convenient way for you to get started. It works well for lightweight stream processing use cases. We also have support for different type of protocols, all the way from Kafka to MQTT. And based on the Kafka protocol is where we have the Kafka compatibility. We call it Kafka on StreamNative, right? So that's a quick overview of the StreamNative platform. So really, I want to touch a little bit about some of the core use cases around stream processing. I think these use cases are very common these days. There are a whole bunch of more use cases which are popular, but I just want to touch on a couple of them. I think in this brave new world, I think we have need for access to data in real time. And there are different types of industries who really have this need more than others. Definitely in fintech for threat detection, fraud prevention. There's the IoT device, IoT industry with all kinds of devices sending, tons and tons of data and needing a way to monitor, all that data which is happening so that, some sort of analytics can be derived out of that in real time. So there are different verticals which have need for access to the data in real time. And we're going to talk more about this, but I think these are some of the industries which we kind of focus on to help them accomplish their data stream processing needs. So if you think a little bit about a data platform, end to end, there are different components, there are different building blocks of a data platform. If we were to simplify, I'm sure there are more which are more in each of these levels, but all the way from having the ability to connect to external systems, to processing the data as it comes into StreamNative Cloud, and keeping an eye on what kind of data is happening, ensuring the quality, and applying certain rules into the data as it comes in and governing it, and sharing that and to a destination where you really want to land your data so you can quickly get insight into analytics. So these are like some of the core blocks of a data streaming platform where we leverage basically StreamNative Cloud. And of course, I think as we look at this, different building blocks end to end, we also explore them with our partners. So as to how do our partners kind of come into this, and where do we sort of work closely with them to kind of help our customers sort of with connectivity or processing related use cases. So Sarva, anything you want to add here in terms of how you look at these building blocks from an integration perspective with Timeplus and StreamNative, or in general about any generic data platform need?
Yes, definitely. Thank you for calling that out. We also sort of work based on these principles within Timeplus itself, but also within the kind of wider ecosystem of processes, right? Like StreamNative and so on. I like that this is this is drawn as a cycle, right? So it is a virtuous cycle, right? The more connectivity you can bring into your platform, the easier then you can tie up data coming in from different systems, and then publish it out to consumers either within your company or even outside of your company. And definitely governance is always a key part of that, right? Like seeing whether the data is fresh, whether the quality is good, whether it's being accessed by the right people, and so on.
Absolutely. Yeah. So let's look at some of the specific use cases here, which are more popular. I'm sure there are more, but we just want to touch upon a couple. Like again, thinking about we are in 2024, end of 2024, 2025 is getting started soon. I think we don't need any convincing now at this stage that there are industries which need access to data in real time, right? In fact, actually, people want to know, tell us how can we do it very quickly in a cost-efficient way. And there's so many different aspects to it. So if I were to just touch upon one or two, like if you think about monitoring and alerting, like, every company is a software company these days, like, in respect of what vertical or industry that is in. The software teams who are building out, their automation systems, they always want to keep an eye on how the systems can, running and behaving, and not having the ability to get notified through an email or a Slack or PagerDuty or other type of, like, mechanisms for notification is something you can't even live without today. Like, absolutely, there's a need for it. So as and when something is breaking or systems are not scaling, it's critical for companies to identify and get notified about those type of scenarios, right? Also, fraud detection. Think about a scenario like, can banks be without notifying the customers about someone, anomalies, and anyone logging into your account, a bank account? That's something which is very given today. I think it's absolutely a need. So I think now it's more and more about how can we actually help these verticals for these use cases, and how do we actually make it easier for them to quickly adopt these platforms so they can implement the use cases and really focus on the outcome, right? So, Sarvar, any thoughts you'd like to share on this? What are you hearing from your customers, your partners in the industry about some of these use cases?
Yes, definitely. So, as you mentioned before, the kind of volume and sort of velocity of data has increased so much, right? You can't physically even just look at it all in different systems and then try and tie it together. So the role of like stream processing engines and streaming platforms becomes really, really good here. The other thing is also humans aren't quick enough to react as well, right? So although you have like, monitoring and alerts going out to SREs and system administrators like that, but increasingly now we're seeing like the consumers of these alerts are other softwares that have to take some sort of mitigating action, right? If there is like a DDoS attack or a cyber attack going on in the middle of the night, you want to ensure that the kind of checks and balances are taken care of as soon as possible, rather than having to wait for somebody to wake up and figure out what's going on.
Absolutely, absolutely. So yeah, it's critical now to to can implement these use cases and not just get notified, but hopefully also have as much as possible automated way to take action on it. So yeah, interesting phases we are in right now when it comes to data stream processing and data platform or data streaming in general. Um, so in that context of the fact that now I think most companies are very convinced about the need for accessing data in real time, I think it becomes more about, how can they do it very quickly? There are challenges of setting up an infrastructure for your data processing needs, right? And there's so many different types of technologies out there. So I think one of the key things now is more about main questions I hear all the time is, yes, I don't need more convincing about the access to data in real time, the need for moving away from batch processing and going to the data stream processing. But it's more about how can I quickly, set up an infrastructure in such a way that I can focus more on my data pipelines. I can focus more on the platform and the outcome of that rather than worrying much more about the infrastructure, right? Like some of the couple of examples I'll touch upon is as you set up any infrastructure for a data platform, particularly for processing your data as it's coming in real time, they're like based on the frameworks you adopt, you either have to, like, worry about the type of binaries you deploy. your custom business logic you're deploying, and many other aspects, right? And in terms of particularly the managing the state, you have to worry about how the infrastructure is going to handle that. So there is really a huge value in having a service which can be relied upon when it comes to your data processing needs, and particularly a simplified infrastructure, right? So in that context of having an ability to set up an infrastructure for data processing very quickly, easily, with just a matter of few commands, I would like to now hand it over to Sarvar, who can talk more about Timeplus.
Thank you. So that slide was really great, right? It highlighted kind of the challenges of setting up the data streaming platform, as well as the supporting tools to get the outcomes that we talked about, the great outcomes we want to achieve. But then the biggest problem is that the time to set all that up before you can hook it all up is high, as well as the skills required to learn how all these things join together. So you need DevOps skills, you need data skills, you need software engineering skills, and you also need to have the infrastructure, right? You have to purchase or provision that infrastructure wherever that may be. You have to learn how they kind of interact together. Do they work together? And then there are day two operations as well, right? Like what happens when things go down? How do you observe that? How do you do that? So the time to market an idea then is then measured in months, if not years, in some organizations, right? So I'll start with this slide here. It's a little bit bold, but it's if I had 30 seconds in an elevator with a CTO or an architect, this is what I would say, right? In fact, we actually use this slide at Current, and people have this light bulb moment of, yeah, that's true, right? Like I have to hook up something like Kafka to publish and subscribe to data of different shapes and sizes. Then I need a processing layer like Flink to do very flexible stateful and stateless processing. And then typically I have to land it somewhere else, right? Maybe in more than one system. So it could be a data warehouse, it could be a data lake, it could be just other applications. And then perhaps you get some analysts or data scientists or other software engineers making use of that data. So at Timeplus, we thought, well, in the smallest case, right, the smallest use case, I just want to be up and running, right? Let's say I have some streams of data coming from an app, and I want to do some stateless and stateful processing to derive more valuable data from the raw data, and then be able to serve that in a single binary. What would that look like, right? So that in a nutshell is what Timeplus is. Next slide. And so once you have that single binary, in that single binary, you can still get quite a lot of these facilities that you used to have in different dedicated components, but you're up and running very quickly. So here we have connectivity to your most common systems like Apache Kafka, Apache Pulsar. You have HTTP WebSockets that are used by software engineers and kind of data services alike. And in there, we want to democratize the usage of this platform to create more valuable data from the data sources that you already have. And the way we do that, the core language that we do all this in is in SQL. So SQL is quite common. There are different variations, but at least you get a much wider audience of users than software engineers. You can set up these pipelines quite simply using a few lines of SQL, and they can also get very complex. And then in the engine itself, we also have like Python, JavaScript, UDF to extend those functions that you call in Timeplus. And yeah, just using using SQL and some small Python and JavaScript extensions, you can get something live maybe within days, right? Within hours or days if you know what you're doing, right? In the core of Timeplus is this like streaming, storage, and processing framework. And so what we do is we think of everything as a stream, right? And I'll speak more about this in the next slide, but the bottom layer that you see there is a storage layer, very similar to what you see in Apache Kafka and Apache Pulsar. Each stream is backed by a write-ahead log and a sort of a table store. I say table store because you can choose whether it's a row-based storage or column-based storage based on the kind of like performance or functional semantics that you want it to behave as, right? And you can either publish data directly from your applications using some SDKs, or you can bring them in using connectors and things like that. But one of the things we're really proud of at Timeplus is we've tried to simplify like the common things, right? So we have connectivity at the layer of the engine to be able to natively read from certain sources and write to certain sinks, right? And so among these are Apache Pulsar and Apache Kafka and ClickHouse. And that makes it such that even with the single binary, you don't need to install yet another thing to scale up and manage if all you need is just to treat these external sources and sinks as if they're native streams. Next slide. So in here, we can look under the covers a little bit. So in Timeplus, pretty much everything is a stream, except maybe the ClickHouse table. And so we like to think of the stream as this abstraction, right? So it's very similar to a topic, right? A Kafka topic or a Pulsar topic that you're publishing to and subscribing from. But behind the scenes, you can then so the difference here is when you declare a stream in Timeplus, you're immediately attaching a schema, just like you would in a database table. So immediately it has fields. There are different types, but field could be just your typical primitive types or maybe JSON or something like that. And then you can interact with that stream either as a stream or as a table, right? So if you interact as a stream, then essentially you subscribe to it, and you can ask it to be filtered, or you can maybe even run another kind of derivative SQL on top of it to query the data live as it's coming in, right? So you give it a query from your application, and then whatever meets that query comes to you in a streaming fashion. But as a table, you can do some very interesting things, right? So it's a table you can look back historically and treat it almost like a database table or a data warehouse table as well. Of course, now we're blurring the lines with the operational databases and data warehouses, but it's not that blurry when you think of like data coming at very high speed, and you may want to compare it with something that happened in recent history. So let's say your average transactions in your bank account right now versus the last 5 days, the last 30 days. This is the kind of thing that allows you then to do features in a fraud detection pipeline or something like that, right? You need to combine both the historical data with the live data. So of course, we're not always lucky that apps can push data directly to Timeplus. This data may be sitting in other systems and then exposed via Kafka for various applications or Pulsar, as the case may be. And so we have this concept of a external stream, which mimics a native stream. So you can think of it as a virtual topic, right? So we just declare it. It has some connectivity details to that external source or just external system. And then you can interact with it in almost the same way as you would a native stream. So you can query it while the data is already sitting there, right? If the data is sitting in Pulsar, I can just do a SQL query just to explore the data. Like, what does it look like coming in, or already stored there? And then where you start cooking with gas is to mix and match these different streams, join them, aggregate them, transform them to create the insights that you need for your downstream app. So your downstream app could be something that needs to mitigate a thing that's happening now, right? So in the case of DDoS, for example, we have a customer where if you cannot mitigate that in a minute automatically, then you've not done your job, right? The data is coming in at a very high rate, maybe like 1 million events, network traffic events a second, and you need to be able to calculate the probability that there's an attack going on like very quickly, right? So we join these streams. We run almost warehouse style queries on the live streams coming in, and as soon as a signal is detected, then some data is written to another stream, and then that's picked up by a mitigator application, which will, let's say, block some IPs or IP ranges downstream. The external stream is also used to write data out, so we can write data out to Apache Pulsar, Apache Kafka, ClickHouse as well. So a little bit about ClickHouse. ClickHouse is coming up now as a very, very fast real-time data warehouse where you perform quite like high cardinality aggregations or analytical queries. Timeplus, it's written in C++. It originated as a fork of ClickHouse a few years ago. And what we've done since then is written a stream processing engine based on the knowledge and best practices that we've read in the literature and from other systems in the ecosystem. Right. So writing to ClickHouse or reading from ClickHouse is very easy. But also we make use of some of these ClickHouse engines. For example, a merge tree is the common kind of database engine inside ClickHouse. We make use of that internally for some of our tables, right? So if you have a regular append-only stream, it has a columnar store, and we use a ClickHouse engine for that. We also make use of RocksDB for when you need a row style table. I won't harbor too much about that here, but that's also useful in some cases. Maybe not for aggregations as much, but more about data retrieval. Next slide, please. So if we zoom out a little bit, what kind of architectural patterns can Timeplus serve alongside a streaming platform like StreamNative? So one very common approach is to have a streaming platform in a centralized location, right? Whether it's in your data center or in the cloud, and have the processing engine, in this case Timeplus, sit right next to it, right? So as the data comes into these topics from your source applications or your connectors, then the processing engine is right there to be able to enrich that data from other sources if that's necessary, and then create these data products. The term data mesh is very popular, or was popular very recently, but yeah, so the idea is that from the incoming data, you may not have the insights in one place in the form that you wanted. So then the Timeplus would help you to join, enrich, and create these data products that are more usable downstream. So this is the most common one. In this case, then Timeplus can serve the data either as a streaming query from your applications by various SDKs, right? So it will just start up, give a query, and then as the data meets that query, then it's automatically pushed to the app. But you have more traditional applications which cannot do streaming queries. So maybe it's a web service or a BI dashboard or something like that. And we have the ability to run just your typical table queries, or what we call as historical queries, to Timeplus as well, as if it's a normal database. So there is a JDBC driver, for example. If you have a Java-based BI platform, you can set up a data source using the JDBC driver and then just almost treat it like a database. Next slide, please. So another architectural pattern here, because Timeplus is so small, it's a lot of functionality shoved into like a single 200 megabyte binary. You can use it for these kind of like hybrid cloud or hybrid region scenarios. So for example, in a edge case scenario, you can install Timeplus on these devices, and as the data is being produced on the devices, you can use Timeplus to aggregate and downsample and only send the relevant data to your cloud data warehouse. So this kind of improves the throughput, but also you're probably saving on bandwidth costs and computation costs, having to take all this raw data and then throw most of it away, right? So in that scenario, you can do this thing. The other thing we have also is something called data virtualization, where between Timeplus instances or between Timeplus clusters, you can almost treat them as one, right? If you have sources of data coming from, let's say, US East and US West, and maybe you want that aggregate insight, but you don't have to necessarily bring all the data into one location before doing that, before merging that. You can federate the queries. The queries will be pushed down to the local Timeplus instances, and then they will give you the data according to the query that you gave it, and then you can merge it in the centralized Timeplus that you see there. You can mix it and match these architectural patterns based on your use case. Some of them can be very small with just a microservice app and Timeplus, and some of them can be very large like this, where they're chained together. Great. So this is demo time.
Let me hand it over to you. Let me stop sharing so server can present.
So let me know if you can see my QuickTime.
Yeah, I can see. Yeah.
So this is showing kind of integration with StreamNative Cloud. We have a Pulsar cluster here with a topic, and here the StreamNative portal is where you can get the location or the coordinates to your Pulsar cluster. And we come to the Timeplus console. So this is a UI wizard. You don't have to use the UI user to create the external stream, but it's helpful in the beginning when you're exploring. So we copy over the Pulsar server and port, the API key from the JWT token. If you then specify the location of your topic here, so you've got a namespaced topic. This one happens to be JSON. You can preview that data before creating it. Here you can see the SQL command. So if you were to have to do this in like CI/CD, right, GitOps, you would just be creating that SQL, and that itself would set up the external connection. And once you've done that, so this is a streaming SQL query running. You can run more complicated like queries, like a tumbling window with group bys and things like that. And as you can see, this is a streaming SQL. So as the data keeps being published into Pulsar, then you're getting the enriched data coming back as well in a streaming fashion. So the Kafka as an external stream has been there for quite a while, and seeing as StreamNative now offers a Kafka endpoint for the same cluster, we can just show that here very quickly. So pretty much the same experience. Copying over the Kafka endpoint using SASL SSL.
Oh, server, I think no, I'm not able to see the screen. Give me 1 second. Oh, no, I can't. Sorry. Sorry for the interruption.
It did drop a little bit from the screen that I'm seeing, but I'm still sharing.
Yeah, no, I can see. Yeah.
Okay. And there you have it. So that's consuming from StreamNative Cloud using these two mechanisms.
Awesome. Okay, let me just bring it back. Let me share my screen. So great. I think that was thank you, Sarwar. That was really a quick and instant experience of connecting to StreamNative just with running a couple of commands. So I think super simple. Okay, so I think if we were to again come back to we covered a few topics. Again, we don't want to load too much of content into this session. So if there are a couple of things we wanted you to take away from today's session, let me touch upon one, and I'll let Server add a little bit here. Again, I think between StreamNative and Timeplus, we are definitely very committed and focused on exploring always to kind of build that native integration experience for our customers, with focus being like on simplified infrastructure so that our customers, our developers have to do less to really get started, and they get started quickly, right? And then have instant access to like an integration which quickly gets the data flowing between Timeplus and StreamNative, right? So, Sarva, anything you want to summarize from your end? You covered a bunch of things today.
Yeah, it's really about being able to be up and running with a an app, a data app, if you will, within hours, if not days, right? And having the usage of the external stream component, so that's written in C++ using the C++ client from StreamNative, and that negates the need for additional hops to other like connector type components. So you can reduce latency and get higher throughput right from the same place. The other is it gives you flexibility to try out different architectures which you may not have had before. So some of the existing systems allow you to do centralized processing, but then if you want to do like federated, it becomes more complicated. But this allows you to do replication and data virtualization quite easily as well.
Got it. Cool. All right. So that's pretty much what we wanted to cover today. I think keep it very focused on some of the work we've been doing together between StreamNative and Timeplus. And I think some of that we'll share a little more on the collateral side, on the more information about where you can find documentation, other details shortly. But I think, again, if you want to, for the folks who are also new to StreamNative, and if you want to get started very quickly, you can scan this barcode to, sign up for a free trial. If you want to book a demo, then you can use this link here. And we'll definitely get on a call to, set up a demo for you and understand, what your, requirements are, so that we can customize the demo for you and things like that. We also recommend that you go through this book on Apache Pulsar. You can scan this to get access to a link to get a free book. Very well written book by David, and who's got like more than a decade of experience in Apache Pulsar. So it's going to be very informative for you to kind of go through this. Please scan the barcode to get the book. All right, so Sarah, you want to cover something on Timeplus and?
Yeah, so there are again like two ways to consume Timeplus. So we've got a enterprise download, either as a single binary, or if you're doing clustered setups, you have like bare metal binaries, you've got Docker instances, and you've got Kubernetes. And again, there's a free trial for, I believe, oh yeah, there we go, 30 days. And if you're just exploring, without wanting to set up something locally, then you've got Timeplus Cloud. That's also a 30-day free trial, 14-day free trial. Apologies, on Timeplus Cloud.
Great. Looks like there's a blog which is now published very recently, just like a few minutes back, like less than an hour back, I guess. So feel free to go through that. This should be on Timeplus blog's site, right, Sarvar?
That's right. Yeah. So we'll post the links on in the collateral and also on LinkedIn. But yeah, this is now available in GA and in Timeplus Enterprise 2.5 and onwards.
Got it. Okay. And then there's also a demo now on YouTube. And Sarvar does this so that viewers can watch this at convenience, slow down and watch it in more detail. But does it pretty much cover what you covered, or it has some more stuff? Anything you want to share here?
Yeah, I believe so. I think it's got another voiceover, but yeah, it covers most of the stuff that I've shown.
Okay, awesome.
Welcome to this demo showcase.
I'm sorry. Okay. All right. So I think that's all we wanted to cover. Let me then go to the chat and the Q&A section to see if there are any questions we have. I think there are a couple. Maybe I can go with look like there's one question here. Maybe I'll pick that up first. Will this integration work with StreamNative Cloud? So yes, I think it basically, even though the integration is very focused on Apache, it's a Pulsar integration and a Pulsar connector which integrates Pulsar and Timeplus. But it's being tested and validated with StreamNative Cloud. And it is basically validated not just the Pulsar connector, but also the Kafka-based native integration, the external stream functionality, which Sarvar Kenneth spoke about. That is also validated with StreamNative Cloud. So the both Pulsar and Kafka integration works, and it's tested and certified by Timeplus. Okay, let's see what else is there. So when will this Pulsar external streams be available? Do you want to take that, Sarvar?
Yeah, so as I mentioned, it's been released in Timeplus Enterprise 2.5. So it should be available from today if you do the self-hosted option. In the cloud, it should be there soon, from what I understand.
Got it. Also,
maybe next week or so.
Sure. I think this one, a couple of more actually in the same context. Does this Pulsar external stream feature work on both reads and writes to Pulsar?
Yeah, that's true. So with an external stream, it's one setup, but it allows you to use that external stream to either read and transform that data, or you can just use it to write. So if you have other streams that you've processed and then you've got some kind of enriched results that you want to publish to Pulsar, you can use that same external connector. The one thing I should note that each external stream that you define already specifies the topic, right? So you just need to create a new one for a different topic.
Got it. And then I think there's one more, if you can help with that one. How is this different from any third-party connector type approach?
Right. So we've always had, we have another connector component, which you run separately to Timeplus. Those connectors have client libraries built in for both Timeplus as well as the third party. And so you'd have to read it, pull it, however those systems are. And then they would use the client SDKs to then publish to a native stream in Timeplus. So then you're duplicating that data. Whereas in this case, it's all in the core engine itself. And because of the way it's written, it's nuanced. I don't know if any other stream processors do this, but the way we set up the external stream, we don't bring the data in. We don't copy any data that we don't need, right? So if you create let's say a derived stream off of that, and you're, let's say, downsampling or creating a materialized view off of like a windowed aggregation, for example, we will only store whatever is computed and required. We don't bring in all the data and then run on it, if that makes sense. So definitely like lower bandwidth, lower computation costs for keeping the full copy of that external data. There's another question on the webinar chat.
Yeah, absolutely. So what is the average latency we can expect if we use both StreamNative and Timeplus to stream data and process it? Yeah.
In the simplest case, it can be low milliseconds, so maybe single to 2-digit milliseconds. It depends on the queries too. So for example, if you're doing a stateless query where it's, let's say, some fields coming in and you're renaming fields, or you're doing a projection, then that can be very, very fast. If you're doing an aggregation, then you will be specifying some emit strategy. So depending on your business logic, then it'll be whatever that is. So if you're saying like emit me the average temperature every 5 seconds, then it, by definition, it's every 5 seconds, right? But yeah, typically milliseconds, right? Single to double-digit milliseconds. With more complicated, if you have like a high volume of data coming in and you're doing very complicated aggregations, that can then run into hundreds of milliseconds or seconds if you have multiple hops, for example.
Got it. Okay. Sounds good. I think, let me just see, there might be one more. Does the Kafka compatibility mean I can run Kafka streams apps on Pulsar? Yeah, so maybe I can take this. So I think essentially Kafka compatibility means that we are using a protocol on top of our Pulsar infrastructure. So the Kafka protocol. So essentially which means that that protocol is enabling Kafka app-based applications, whether it's producers, consumers, or other type of clients, to interact with our data platform, which is built on basically for the StreamNative cloud, right? So the protocol sits on top and basically does the interaction, but underneath that interaction is our core infrastructure from StreamNative and for Pulsar. That's where I think if I go back to a little bit about how StreamNative started contributed to Pulsar, and this was like a few years after Kafka came out. And I think the advantage Pulsar had was it was built on top of all the cloud native capabilities like Kubernetes and other things, right? Unlike Kafka, which was like really built on top of HDFS and some of these other older kind of legacy systems. So as Pulsar solved some of these problems and designed to scale right from the beginning, you leveraging the cloud native infrastructure, we realized that it would be helpful to also offer these same capabilities to the Kafka community for existing Kafka users who are using Kafka-based applications. If they want to still interact with our platform, this protocol allows them to do that very easily, by just redirecting all their Kafka-based applications to kind of StreamNative cloud, right? So yeah, I hope I answered your question there. Yeah, so I think that's pretty much it. I think we covered most of the questions here. So Sarwar, thank you so much again for your time. This was really helpful. And again, I know we are going to share some more content on our social channels on the Timeplus side and StreamNative side. There is the blog and some more material which is available in the form of a demo on YouTube on Timeplus YouTube channel. And yeah, stay tuned for more of such updates between like Timeplus and StreamNative. We are very committed to working closely and collaborating on, exploring ways to offer again, value to our customers and our partners, right? So yeah, thanks again, Sarwar, and
glad to be here. Thanks for having me.
Awesome. Thank you so much. All right, so we'll end this session now.